Hello and welcome to my video on item to binary encoders. Today I'm going to show off the two designs that I have made right there. And I'm also going to show you how you can make your own or some components you can use to make your own, some general tips and information, as well as how I arrived at my setup. But first, I believe credits are in order. So credits to Pala Pala for the concept for the original, for creating the first encoder essentially. Then I used Obi's encoder as template, like his logic as a template for my own. I want to thank Kartoffel for developing his own and uh, allowing me to take some ideas of his and apply it to my own. Shmo for working on encoders with me, just in general. Love you. Monica for showing a lot of different ways and helping me optimize sending the card up. J Roy for making several different control wiring variations while I was still working on mine, and as well as uh, working out working out a lot of ideas and theories and wiring with me. So thank you for that. RT5H3 for helping me do some control wiring. And last but not least, 51 Mayday for helping me really early in the beginning with some of a Waterstone and a lot of other stuff, like showing me his encoder. Um, yeah. So to explain the theory of what an encoder is, also I will be going through uh, where people contributed more later on. But to really get an idea of how an encoder works, it's essentially something like this. If we imagine these are the chests and the items we want to encode. Did I skip yeah, I did skip a chest. Um, so the idea is basically we are creating the binary pattern through these chests. So you can see that the emerald block is in the first, is in binary code number 1, and we have golden block number 2 at the slot number 2. If you do not know how the binary system works, I would suggest looking that up and then continuing to watch the video. So right here you can see gold block corresponds to chest number 2. Then so on and so forth. We have diamonds in both the 1 and 2 chests, which would make it the 3. So um, how do we encode a new item? Well, or how does the encoder work? Well, basically we put an item under the hopper, unlock it, and then you'd run this hopper under each one of these chests and then take a readout from the chest. And that is essentially what we're doing. Now, right here, I have a few item types assigned, but it's not all of them. So I will leave a world download. And if you want to get a little bit of an understanding for this, you can go ahead and fill this out. So I will do a little bit of it for you right now. So as we can see, we have a couple deep slate on the 4th bit. And so we'll put it in the 4th chest. So that's it for getting the general premise. Now let's get into the designs. The designs themselves are pretty simple, pretty small. I'm very, very happy with them. It is a 19 plus design because it utilizes cart yeeting right there in order to keep out any items. It is 100% reliable, which a previous design was not. It failed about once every 31 million times. But it should be 100% reliable now. So, excuse me. That being said, let's just get a shulker box and give it a little test run. It has a very cool feature where it separates empty shulker boxes, and you're about to see that feature in action right there. Go straight into this shulker box. If we take that out and put an item into it this time, there you go. We will, it will then not dispense the box. Now, no, inventory is pasted correctly. Very, very nice. Yep. So we trigger it a second time. you'll see that the box is not getting dropped out. And when the encoder is fully reset, we're going to get the box output right there with the gray concrete. So that is pretty much it for how the encoder running. Now, as for the error codes we have here, we have something went wrong, which is this general lamp right here. If something has gone wrong, this lamp will always light up. However, we have some more precise lamps, like cart did not launch. Now, this one is a lamp that flickers, so throughout its running, you might actually see this flickering. We have sorry, we have loose item input, which is if you basically input an item right there. This gate, which this is what RT came up with. This gate is going to activate, which is going to lock up the encoder. I have a secondary latch right here, even though it's not necessarily required, in order to make sure that the player realizes, oh, hey, this is what went wrong. So this is loose item and input. And then we also have the chests didn't reset, which is an item didn't get returned to the chests. And that is a lamp that does not flicker, in fact, because of this fader right here. And if you wanted this one to not flicker, you could also attach a fader to it. But it's, yeah. So that's pretty much it. And then right here, we have one which with all of its control wiring ripped out, except for the breaking of the shulker box if the box is empty. Also the locking of the hopper if the box is empty. Because those are two important features. Now let's talk about how to make your own. So there are a few ways to send the card. Number one, which is the slowest, is powered rails. Then we have this curved rail shenanigans right here, and we have a piston bolt. Let's just see a speed comparison. And as you can see, there's quite a difference in speed between them. Next up, why are we using a piston bolt under the chests? Why not use power rails? Well, here we have some pieces of paper, and if we hit this, because the cart only stays on each rail for a single game tick, and a hopper cart sucks one item every game tick, it is going to make a complete message. So just to show you an example of what would happen if we tried to do the same on powder rails or anything other than a piston bolt, we are not going to get a complete message. Now, for sending the cart upwards, there are a few different ways you can do it. This is one way that I really like that I came up with, but it's not the design I ended up going with. This one is a cheeky design by Monica, but it has a little flaw. But let's see it in action first. The flaw with this is that if you have another chest right there, we are going to get an issue. And this one works based off building up 8 snow layers and then placing a rail on top of that. Next up, this is another pretty simple one. This is the one I ended up going with in the encoder. So right here we have a piston, just a repeater, and there. Important to have this on 4 game ticks. Let's see that in action. Now it is important that you have a repeater or some kind of delay there because this is locational, as I found out while making this. Thank you for Monica for both of these designs, by the way. Last way to send the card up is one by Huavi in the Storage Tech Discord. And it uses saw sand. Now, as for this setup right here, it is important to note that these two that are kind of the two contenders in my eyes are equally fast with 8 game ticks of delay in the setup. So here we have 2, 4, 6, and 8 game ticks. If you had 6 game ticks, This one right here is actually faster, but if you do not have 6 game ticks, then they are equally as fast. I.e., you can't send the cart off. You can send this card off too quickly and end up skipping an item. Now, for how this design was arrived to. Oh, right. I should mention this is min hoppers. Yeah, that's a cool feature. So, first off, what is this? Anyways, uh, what I found was, or if you know how the game works, uh, you should realize that you can place a cart and a shulker box in the same game tick as long as you get the right update order. So here we have a few rails which have the opposite update order to what you'd intuitively think. So this, and that causes, sorry, this cart to be placed first and then the shulker box. Now, um, combine that with another cool little feature is in that if you place the cart in the same game tick as you power a piston, the cart will stay on the rail for exactly 1 game tick, and then it will be pushed over to this side. Now, here is where Kartoffel's one of Kartoffel's tricks really came in clutch. So what we're doing here is we're actually dispensing the hop cart on the rail, and then as buffer items, we're sucking out more hopper minecarts. So let's see that in action. This allows us to not only get a empty box proof encoder by just removing this item type, and then it sucks out another item. So all we have to do to really secure that is by giving it, letting the cart sit for at least 5 game ticks on this rail before it can move along. Now here's another layout I made that is using precision hoppers, although that isn't needed to get 100% reliable collection, at least as far as we currently know. But it is something neat, and I do love my precision setups. So let's just kind of see that in action. So first we have the box getting dispensed, item gets sucked out, then we dispense the cart, and then you'd fire it off. This is a lot less precise in terms of timings. But yeah, that's gonna do it for this video. Thank you very much for watching. Goodbye. Sorry for the scuffness. I do not record scripted.